Hi guys, welcome to another lesson. So in today's lesson we focus on the cast diagram. So it says in the diagram below we're given point P that's defined by the coordinates -2 and -1, and they tell us that this point lies on the third quadrant. OP is r centimeters and the axes intersect at O, which represents the origin on the sketch. So when analyzing the given sketch, we can use this point P and its coordinates to define the sides of the triangle. So the x-coordinate -2 simply means that point P is 2 units away from the origin on the negative x-axis. And the y-coordinate -1 indicates that point P is 1 unit away from the origin on the negative y-axis. So we can actually label those distances, and we also need to bear in mind that the given triangle is a right triangle, so we can use Pythagoras theorem. So let's move on to the questions. So it says using the sketch and without using a calculator, calculate the length of OP. So OP on the sketch is this line here, so we need to calculate its distance. So we can apply Pythagoras theorem. So we can say the square of the hypotenuse is equals to the square of the sum of the squares of the other two sides. So this is equals to x is -2 squared plus y -1 squared. So this is equals to 4 plus 1. So OP squared is equals to 4 plus 1, which is equals to 5. Therefore, OP should be equals to the square root of 5. So the second question says we need to find the value or calculate the value of square root of 5 cos theta for cosec squared theta. So here we're dealing with a trig ratio, and here we're dealing with a reciprocal trig ratio. So before we delve into the question, we need to first define our trig ratios and our reciprocal trig ratios. So we can use these trig ratios to help us find cos theta, and we can use the reciprocal trig ratios to help us find cosec theta. So if you pay attention to the sketch, with respect to theta, this is the opposite side, this is the adjacent side, and this here is the hypotenuse. So we can label these different parts on the triangle. So let's already define cos theta with respect to the sketch. So we know cos theta by definition is adjacent side over the hypotenuse. So the adjacent side on the given sketch is -2, and the hypotenuse is square root of 5. But we do know for fractions we don't want a surd in the denominator, so we need to rationalize the denominator. So you need to multiply by square root of 5, square root of 5. So square root of 5 times square root of 5 is 5, and -2 square root of 5 in the numerator. So we already have cos theta to be -2 square root of 5 over 5. So now we have to define cosec of theta. So cosec of theta is equals to 1 over sine of theta. So let's quickly find sine of theta. Sine of theta by definition is opposite over the hypotenuse. So the opposite end is -1 over the hypotenuse, which is square root of 5. So now that we found sine theta, we can easily find cosec theta, because we know cosec of theta is the reciprocal of sine theta. So this is equals to 1 over -1 over square root of 5, which is equals to 1 over 1 times square root of 5 over negative 1, which is equals to negative square root of 5. So now that we have cosec theta, we can write cosec squared of theta. Cosec square of theta is equals to minus square root of 5 squared, which is equals to 5, because minus 1 times minus 1 is 1, and square root of 5 times square root of 5 is 5. So now we can substitute cos theta and cosec squared of theta to find the value of this whole expression. So we can say this is equals to the square root of 5 multiplied by cos theta is minus 2 square root of 5 all over 5 plus 4 times cosec squared of theta is 5. So square root of 5 times square root of 5 is 5. So this is equals to 5 times negative 2 all over 5 plus 20. So 5 and 5 cancel. So negative 2 plus 20 is positive 18. Thank you for watching. See you in the next one.